Hello students, welcome back. We completed the essential materials. Now let's do some applications. The first application in section 5, that's not going to be too bad. Still, it's a bit difficult, so if you don't understand everything at the first try, that's not going to kill you. We're going to come back to this and work out over and over again. And as we repeat, gradually you're going to gain some proficiency, and eventually, hopefully, you'll be able to do this. Okay, here's the structure. We are looking for a tangent line, and the most useful form for us is the slope point equation. x0 is given, and how do you find out the point? Well, we have the graph, so plug in and we have point y0. How to find the slope? It comes from the derivative computation. In the end, that's the answer. Does it make sense? Well, maybe not. Maybe not. So let's work out through a couple of examples. Okay, here's the first example. Let's see. I already created this graph. Let's see. Yes, right here. I don't want to show you these yet. This one here. Y equals 1/2 x squared minus square root of 3x. That's the graph. We have square root here. X is inside, so I don't have anything here when x is negative. Domain is when x is greater than or equal to 0. X equal to 3 is right here. Right here. About 1.5, and indeed 3,3/2 is the point that I'm interested in. And then I want to find out a slope of the tangent line, and that turns out to be 5/2, and if I put together, and okay, that's a tangent line, but of course that's the answer. We didn't find it yet. We didn't find this one either, to tell the truth. So we start from here, the graph. We saw it. All right. Okay. Step 1, let's find out why not. F of x naught. So in this case, f of 3. So plug in x equal to 3 here. What do you get? We have 1/2 3 squared minus square root of 3 times 3. So what is this? 3/2. No. 3 squared times half, so 9/2. And then there's a square root of 9, and square root of 9 is 3, so 9/2 minus 3, so this is 6/2, 3/2. So why not is 3/2. So we have the point 3, 3/2. Let's go back to the picture. 3, 3/2 right here. See this? 3, 1.5. We found it. 3, 3/2. Just plug in and do your computation. You can use calculator. Next, the derivative computation. Remember, the derivative is the slope of the tangent line. We are looking for the tangent line here. So the slope of the tangent line, we have to do the derivative computation. So let's find out the derivative. Well, let's see. Before doing that, let's note that f of x is 1/2 x squared. So far, so good. But the square root expression is pretty bad because which rule do we have? We have the power rule. So let's express this in terms of power function. Let's see. Square root of 3 is there before, so no question about that. Now x is inside the square root, so that x has actually 1/2 power. Okay, now you're ready. Take the derivative. One half times 2, sorry about the typo, times 2x to the first power, if you use the power rule. Subtracting 1 from the power, but nobody writes like this. 2 times 1/2 is just 1, and then just x, minus square root of 3, and then the times 1/2 x to the negative 1/2 power. That's a derivative function. Alright, okay, that's a derivative function, and let's find out the slope. This is not the slope, this is a derivative function. In order to find out the slope of the tangent line, you have to actually plug in a number and do your computation. M is f prime of 3. So 3 minus square root of 3 over 2 times 3 to the negative 1/2 power. And good way to handle this is to punch into calculator actually. Another way to do that is to use this kind of computation. Negative 1/2 power is 1 over 3 to the 1/2 power, and 1/2 power is square root. So that's what you get, and you see a simplification. Square root of 3 here, square root of 3 there, cancel each other out. We get 3/2 like this. And what is this? 6 minus 1, 5/2. Of course, you can punch this into calculator. In any case, we have the slope 5/2. We have the slope, we have the point. So we have equation of the tangent line. So in this case, y equals to slope 5/2 x minus 3 plus y naught 3/2. That is the equation of the tangent line I'm looking for. The slope point equation of the tangent line. Do not waste your time breaking off and then making it into a slope-intercept equation. I like this one better. And then let's go back to this Desmos graphing calculator. There you go. We already did this 5/2 x minus 3, 3/2. That's a tangent line, and as you can see, indeed, it's a tangent line. Right here at x equals to 3. Okay, alright. That completes the problem. Do I have answer key here? Yep, y naught value. The derivative. Oh, I use a lot of square root expression. Oh, that's too scary. And then the slope computation. And finally, the slope point equation. You can simplify into slope-intercept equation if you want to, but only if you want to. I like slope point equation better, and that's sufficient. Here's a visualization through Mathematica. And yep, right here. Do you have time for one more? Okay, alright, let's do this. Step 1, y naught? So g of x naught, but in this case, x naught is 1, isn't it? So here in this expression here, plug in x equals 1. Let's make a little bigger. So x equals 1, square root of 1, and this is 1 squared, and then this is times 1, and then square root of 1. So what do you have here? Times 1, and then another times 1. That all goes away. It's just multiplication by 1. And let me copy and paste. So this one all goes away because that's multiplication by 1. And that's 1 minus 1 plus 4. So the numerator is 4. Denominator, square root of 1 is just 1. So what do we have? 2. Of course, you can punch this into calculator. In any case, we have the point. 1, 2. Alright, next, the derivative. Now, this is going to be a challenge. We have an enormous fraction here. Is there any good way to take the derivative here? Well, the only rule we have is the power rule, so we want some power functions. All right, square root is the same as 1/2 power, and then x, that's first power, 1, square root of x, that's 1/2 power. Putting together, I have 3/2 power. So far so good. And then here's an important trick. You can separate the numerator. Separating the numerator is an important trick, and an extremely important trick that's gonna come back in week 10, week 11, kind of like that. Right now there is an alternative way, so it's not that important, but still it's good to remember. If you have addition in denominator, of course you cannot separate the denominator. All right, let's keep simplifying so that we have a bunch of power functions. Second power minus 1/2 power, so x to the 3/2 power, and then x to the negative 1/2 power, because it's coming from the denominator, and finally 4/2, so 2x 3/2 minus 1/2. That's the power form. Remember, this is the end of the preparation. The derivative computation did not even begin yet. Okay, power form here. We are ready for the derivative computation. This thing is equal to g of x. G prime of x, on the other hand, we are just starting. So multiply 3/2 times 1/2. That's going to be 3/4 x to the, subtracting 1 from the power, 1/2 power. 1/2 was there before, multiplied by negative 1/2, so we have sign change, positive 1/4 x to the, subtracting 1 from the power, 3/2 power, and then looks like this is a derivative function. Okay, all right. Let's plug in x equals 1. Three-fourths times 1 to the 1/2 power. That's 1, so I don't have to worry about it. 1/4, and then 1 to the whatever power. That's going to be 1 plus 2, and that is, what is it? Oh, excuse me. 4/3 plus 1/4, that's 1. Oh, m is 3. As a result, the equation of the tangent line is m x minus x naught plus y naught. That's a computation, isn't it? So y equals to 3 x minus 1 plus 2. That's the equation of the tangent line in the slope point equation form. Let's see, what did he do here? Point, yes. The derivative computation, oh, I skipped a lot of steps, but we have it here. The slope, all right, and then the line, yeah, the same line, and a visualization. Okay, it looks like a tangent line here. Yes, it is. Okay, there you go. A little bit tougher, but there you go. The second example was pretty hard.